Let's practice applying our exponent properties involving the quotient of powers rule with negative exponents. If by chance you find this a little bit tricky with the negative exponents, feel free to check out one of my previous videos where I go over how to do these with just positive exponents. For number 1, we have this expression that has two of the same bases of x, and notice that they are being divided with that fraction bar. Because these two powers are being divided and they have the same base, we can use that quotient property of powers and subtract these exponents. We can then go ahead and rewrite this as one base, writing x, and then we can subtract their exponents of 8 minus 3, and that's going to equal 5. So more simply put, we can say this is going to be x raised to the 5th power. Now for number 2, we have this y to the 8th power over y to the negative 3rd power, and because they have the same bases, we can apply this same property even though we have negative exponents. Taking this exponent up here and subtracting this exponent on the bottom, we can rewrite this as y to the 8 take away a negative 3rd power, so 8 minus negative 3. Now 8 take away negative 3 is the same thing as 8 plus 3 if you add the opposite, so we can say this is going to be y to the 11th power. For number 3, we have this x to the negative 8th power divided by x to the 3rd power, same base, so we can go ahead and subtract their exponents. Let's go ahead and subtract this negative 8 and positive 3 here, so we can go ahead and rewrite this as x raised to the, and this is going to be negative 8 take away 3. Now if we're taking away 3 from this negative 8, it's negative 8 plus a negative 3. If we add the opposite again, that's going to be x raised to the negative 11th power. Now if you had to rewrite this using positive exponents, then we'll save that for another video, but for right now we can just write it as x to the negative 11th power. Here's number 4. For number 4, we have this y to the negative 8th power divided by y to the negative 3rd power, and they have the same base, so we can use that quotient rule. So let's go ahead and take that negative 8 and negative 3 and subtract them, or find the difference between them. So rewriting this, we can write this as y raised to the negative 8 take away this negative 3. Now if we're going ahead and subtracting, again we can add the opposite, so it's negative 8 plus 3, and negative 8 plus 3 is going to equal negative 5, so we can rewrite this as y to the negative 5th power. For number 5, we have a to the 8th power divided by a to the negative 7th power, so we have that common base of a. And so we can use that quotient rule and take that exponent of 8 and negative 7 and go ahead and subtract them. So rewriting this, we can write one base of a, and then we can write 8 take away this negative 7. Now 8 minus negative 7 is the same thing as 8 plus 7, and that's just equal to 15, so we can write a to the 15th power. For number 6, we have this b and b as the bases, so we can go ahead and use that quotient rule and take that negative 5 on top and subtract the 2 on bottom based on those exponents. So rewriting this, we can use that same base of b. We're going to raise that to the negative 5 minus 2 power. Now negative 5 take away 2 is the same thing as negative 5 plus negative 2 if we add the opposite. So negative 5 plus negative 2 is going to equal negative 7. So we can write b to the negative 7th power. Here's number 7. In this expression, we have common bases of c, so we can use that quotient rule and subtract that 8 from the negative 3. So rewriting this using one base, we can write this as c raised to the negative 3rd power minus 8. Now negative 3 minus 8 is the same thing as negative 3 plus negative 8, so we can write that as c raised to the negative 11th power. For number 8, we have d to the 3rd power divided by d to the negative 4th power, so we have the same base of d. And so we can go ahead and use that quotient rule and subtract these exponents from each other. So rewriting this using one common base, we have d raised to the 3 minus this negative 4. Now instead of subtracting, we can add the opposite, so we can rewrite this as d raised to the 3 plus 4 power, also known as 3 to the positive 7th power. So we can use that quotient rule here. Here's number 9. For number 9, this looks a little bit more complicated, but it's going to be more of the same. We just have two different bases here. So notice we have these common bases of a, so we can use the quotient property with those. And then we can use that quotient property with the b's as a different base. Alrighty, so let's start with that base of a. We can go ahead and use that quotient property. Let's go ahead and take that 7 on top and the 2 on bottom and find the difference. So that's going to be a raised to the 7 minus 2 power if we use that quotient property. And then we're going to multiply this by that common base of b. And we can go ahead and subtract 4 minus this negative 5. So I'm going to go ahead and write this is going to be 4, take away that negative 5. Now, let's go ahead and clean this up a little bit here. So for the a, that's going to be a raised to the, and then if we have 7 minus 2, that's going to be 5. So it's a to the 5th power. And then we're going to multiply this by b raised to the what? Well, this is 4 take away negative 5, which is the same thing as 4 plus 5 if we add the opposite. And 4 plus 5 is 9, so this is going to be b to the 9th power. So this would be our simplified expression. In number 10, we have another similar one where we have two different bases, so we can use that quotient rule with the base of c, and then use that quotient rule again with the base of d. Starting with the base of c here, let's go ahead and use that quotient rule. So we're going to write c, and then we'll take this exponent of negative 3 and negative 7 and go ahead and subtract them. So it's going to be the numerator of negative 3, take away the denominator of negative 7, those two exponents. And then we're going to go ahead and multiply this by that base of d. So I'm going to write d here. And that's going to be raised to the difference of 2 and negative 10. So that's going to be 2 minus this negative 10. All right, so that's going to be those two exponents. So let's go ahead and simplify this a bit more. So we're going to have c, and then for this negative 3, take away negative 7. That's the same thing as negative 3 plus 7, which is positive 4. So that's going to be c to the 4th power. We're going to multiply this by d raised to the what power? Well, 2 take away negative 10 can be rewritten as 2 plus 10, and that's equal to 12. So d to the 12th power. So this whole expression is the same thing as c to the 4th power times d to the 12th power. For number 11, we have these common bases of e where we can use the quotient rule. And then we have these common bases of f where we can use the quotient rule once more. Starting off with that common base of e, let's go ahead and write e, and then we can go ahead and subtract the exponents of 4 and negative 3 here. So I'm going to write that as 4 minus negative 3. Okay, and then we're going to multiply this by our other base, which is going to be f. This is going to be f raised to the what? Well, we're going to take that negative 5 and take away negative 8. So it's going to be negative 5 minus this negative 8, and that's going to be that same part that is equivalent. Okay, so then let's go ahead and rewrite this. This is going to be e raised to the what power? Well, 4 take away negative 3 is equivalent to 4 plus 3. That's going to be 7, so that's going to be raised to the 7th power. And we're going to multiply this by f raised to the what power? Well, this is negative 5 take away negative 8, or negative 5 plus 8, and that's equal to positive 3. So we have e to the 7th power times f to the positive 3rd power. Alrighty, now on to number 12, where things change just a little bit because we have these coefficients other than 1. So notice this 4 in the beginning and this 12. We're going to go ahead and make sure we simplify these fractions using their GCF, otherwise everything else is going to be the same. Once we take care of those coefficients, we'll deal with these common bases of a and use that quotient rule. And then use that quotient rule one more time with these bases of b. Alright, so let's start with those coefficients. So 4 and 12, their GCF is 4. So dividing 4 by 4, we get 1. And then dividing 12 by 4, we're going to get 3. So we're going to get 1/3 as our simplified coefficient. And then we're going to multiply this by a raised to the what power? Well, that's going to be using the quotient rule. So we have negative 5 take away negative 7. So I'm going to write it as negative 5 take away a negative 7, just like that. And then let's go ahead and multiply this by b. And then let's go ahead and use that quotient rule one more time. So that's going to be 3 take away this negative 10. So I'm going to write it as 3 minus this negative 10. Okay, so let's clean this up a little bit. So that 1/3 is already fully simplified. So we're going to leave that as 1/3. And then we're going to multiply that by a raised to the, we have negative 5 take away negative 7, which is the same thing as negative 5 plus 7, aka 2, or positive 2. So it's a squared. And then we're going to multiply that by b raised to the what power? Well, we have 3 take away negative 10, which is equivalent to 3 plus 10, also known as 13. So we're going to have 1/3 a to the 2nd power times b to the 13th power as our final simplified expression. For number 13, we have another similar one to number 12. We'll deal with these coefficients first. This 15 and 20, we'll just simplify them using their GCF. Then we'll use that quotient property with this base of c, and then that quotient property one more time with the base of d. Starting off with the coefficients for 15 and 20, looks like their GCF is 5, so dividing 15 by 5, that would be 3, and dividing 20 by 5, that would be 4. So we have 3/4 as our simplified coefficient, and we're going to multiply this by c raised to the what power? Well, we can use that quotient rule. It's going to be 6 take away negative 9, so it's going to be 6 minus this negative 9. And then let's go ahead and multiply that by this base of d, and let's use that quotient rule one more time. So we have negative 2 take away a positive 5. So negative 2 take away a positive 5. Alrighty, so let's clean this up just a little bit more. We have this coefficient of 3/4. Multiply that by c raised to the what power? Well, we have 6 take away -9, also known as 6 plus 9. So that's going to equal 15. Okay, and let's go ahead and multiply that by this base of d raised to the what power? Well, -2 take away 5 is the same thing as -2 plus -5, which is -7. So we have d to the -7th power. Here's 14. 14 is pretty similar to the last couple examples, so we'll take care of these coefficients first, that's 18 and 12, and simplify them using their GCF. Then use that quotient rule with the base of e, and that quotient rule one more time with the base of f. Starting out with those coefficients of 18 and 12, their GCF is 6, so 18 divided by 6 will equal 3, and then that 12 divided by 6 on the bottom is going to equal 2, so 3/2 is going to be our simplified coefficient. Then we have this base of e, and then let's go ahead and use that quotient rule, so that's going to be -2 take away -7. We can write it as -2 take away a -7, just like that. And let's go ahead and use that base of f now, so we have f raised to the what power? Well, that's going to be using that quotient rule again, so it's -5 take away -4. So write -5 minus -4. Alrighty, so let's go ahead and simplify this a little bit more. So we have 3/2 in the beginning, then multiply that by e raised to what power? Well, -2 take away -7 is -2 plus 7, which is +5. So I'm going to raise that as e to the 5th power. And then multiply this by f raised to the, this is -5 minus -4, or -5 plus 4, which is equal to -1. So this would be f to the -1st power. For 15, we have the coefficients here again. We have 16 and 20 this time, so we'll simplify that in just a moment using their GCF. Then we'll use that quotient rule with the base of x, and then use that quotient rule one more time with the base of y. Alright, so let's start with the coefficients for 16 and 20. Their GCF is 4, so we're dividing them both by 4. 16 divided by 4 is equal to 4, then 20 divided by 4 is equal to 5. So we have 4/5 for our coefficient here. Then we have a base of x, and using that quotient rule, we can go ahead and subtract those exponents. -6, take away that -8, we can write as -6 minus this -8. And then we can go ahead and multiply that by our base of y. So let's see what exponents we have to use there. We have a 2 and a -1. So take the top one, which is 2, and then take away the bottom one, which is -1. Okay, so let's condense this a little bit. We have 4/5 out in front as our coefficient. Multiply that by x, or just put an x next to it. Then we have this -6 take away -8, or -6 plus 8, which is +2. And then we're going to multiply that by y raised to the what power? Well, 2 take away -1 is equivalent to 2 plus 1, which is equal to 3. So we can write our simplified expression just like this. Finally, one last example, number 16, we have these coefficients of 14 and 21, so we'll simplify those using their GCF. Then we'll go ahead and use that quotient rule with the base of x, and then use that quotient rule one more time with the base of y. Starting off with the coefficients, 14 and 21 are both divisible by 7, that's their GCF. So 14 divided by 7 is going to equal 2, and then 21 divided by 7 is going to equal 3. So we have 2/3 as our simplified coefficient. We're going to multiply this by x here, and then we're going to go ahead and use that quotient rule. So we have -5, take away this -6. So let's go ahead and write it as -5 minus this -6. And then let's go ahead and multiply that by our base of y. So we have y raised to the what power? That is going to be -9 take away 4, using that quotient rule one more time. So -9 take away 4. So let's go ahead and put this all together here and condense some things. So we have 2/3 multiplied by x. Okay, and let's go ahead and simplify that exponent. So -5 minus -6 is equivalent to -5 plus 6, which is +1. So I'm just going to write a +1 here, but you can go ahead and leave it off right now if you'd like to. And then multiply that by y raised to the what power? So that's going to be -9 minus 4, or -9 plus -4, which is equal to -13. So we can go ahead and write our final expression just like this. And if you want to get rid of that 1 in our final answer, feel free to do so. We can just write it as 2/3 x times y to the -13th power. But again, if you want to write that 1 there, I think that is also okay. So there are 16 different practice problems on using that quotient property, where you go ahead and subtract the exponents if we have the same base. This time we had some negative exponents, and the previous video had some with only positive ones. And in a future one, we'll go ahead and start combining these quotient rules with the product rules and power of a power rule and putting it all together. So if you found this video helpful, please consider giving it a thumbs up and sharing with a classmate or friend who also might find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.